So let's all welcome Jan. He's the co-founder of Brains. So yeah, it's gonna be a really interesting talk. Jan, please welcome to the stage.
Thank you. All right, guys. My name is Jan. I am from Brains, as has been already said. And we're a company that provides basically Bitcoin mining tools. Does the clicker work? All right. We provide a couple of Bitcoin mining tools, starting from the Bitcoin mining firmware for the ASICs, which the talk is going to be about, how we struggled for the past 4 years going down the mining firmware rabbit hole. Then we have a farm proxy. It's essentially meant for the miners who are, let's say, out there at the oil field and their data bandwidth is very precious and they want to aggregate the hash rate. Then we try to upgrade the mining infrastructure, and actually it's becoming, it's getting some traction lately in the form of the Stratum v2, which is an upgrade to the existing mining protocol. Essentially, it's a new mining protocol with security and stuff like that, but this talk is not gonna touch the mining protocol almost at all. And last but not least is a slush pool, so that's the pool that we have been operating since 2013. And we're actually renaming to Brains Pool for various reasons. We want some consistency in the brand, and we feel confident now it's the time to actually do it. It's not very well known, but we actually bought the last part from Slush a couple of years ago, so it's not solely owned by us. So let's get to the firmware topic. Before I talk about the firmware, I would like to give a little overview of a miner anatomy, what it looks like, because not too many people are familiar with the existing machines. What do you see on the top? It's sort of like a shoebox, whatever. This is what the current machines, the latest generation, looks like. Couple fans, big box with the hash boards. There's a PSU on the side, and that's pretty much it. When you look into the machine, all the machines are pretty much the same. There is always a control board, which is essentially a small Linux board embedded system that is running the operating system. And this piece of component is the critical part that is responsible for receiving the mining jobs from the pool through Stratum v1, v2, depending where you're connecting to. It has typically an SD card slot so that you can do manual firmware upgrades in case something bad happens. Or you can boot an alternative firmware through it, for example. And there is the core, essentially some CPU that is able to stream the mining jobs after translating them from the protocol that we use for mining Stratum to something that the chips do understand. And these chips reside on the hash boards. The protocol between the control board and the hash boards is typically some serial UART, SPI, whatever you name it, something very simple, but running really fast because it has to keep up with the results that are coming back from the chips. What miners typically refer to as an ASIC is the whole box that you see on the top, but what an actual ASIC is the chip that is in the hash board. It's an application-specific integrated circuit. In addition to that, because you don't want to fry the machine, it typically has some kind of temperature control. Today, the miners typically use air cooling, which is some fan control, PWM signal being generated, and it spins the fans to an appropriate speed so that you get some reasonable temperature for the chips. It is not very well known that the chips are quite temperature sensitive, so you need to keep them sort of like a car, like a racing car, at a certain temperature, otherwise they underperform. Alternatively, instead of the fans, the miners can now be cooled by liquids, and they could be immersed in some kind of oil. And then it's the responsibility of the farm operator to make sure that the oil is circulating fast enough so that you can extract the heat from the machines. Or lately, there have been some hydro machines in the market where essentially instead of regular heat sinks, they have like a special heat sink where you can flow water. So this is roughly the current layout of the machines that are out there. How it all started. Back in 2017, we were in a situation and we were like very enthusiastic, saying, okay, we have a mining pool, let's upgrade the mining stack one step further. I'm originally an embedded systems engineer, so let's see if we could do some firmware. And we had an opportunity to actually start writing a firmware from scratch for, at that time, Dragon Mints. we were like super naive, thinking, okay, this would be like the first miner in the market that would like really be open source, and we would have some feasible business model. The naivety was, the level was higher than you would expect, but we were like idealists. So by the time we had the firmware ready, the manufacturer actually said that, okay, but we don't like the idea of manufacturing the machines, delivering them, and having say, okay, these have open source firmware. More than that, we actually made that happen that for the Dragon Mints, these chips had a special feature that was not seen until then, until that time, and that was something called ASIC boost. And they were not able to operate without the ASIC boost enabled. But the mining protocol at that time, Stratum v1, was not capable of accommodating these machines. So we were even so stupid that we actually made the protocol upgrade. Somebody who is familiar with Stratum, it's called mining.configure. It's a new message in the old protocol that made it possible for these Dragon Mint machines to actually be set up in production and be usable for actual mining. So when they turned us down, we were like, okay, so we have all this firmware written, but we don't want to throw it away. So we're thinking, okay, what's the most popular machine at that time? And that was Antminer S9s. And we decided, okay, let's port all the work to S9s. Fortunately, because the Dragon Mints and S9s were kind of similar because they were all made in China and they like to look at some each other's designs, right? So it was not so much work. But what was another interesting aspect was that there were rumors that the S9s already were able or capable of doing the ASIC boost. Now I have to explain what the actual ASIC boost is. ASIC boost, it's an optimization when you design the ASIC chip that basically yields up to 10 to 15% of electricity saving because you're basically sharing some circuitry inside of the chip. For the knowledgeable who are a little bit into the SHA-256 is the expansion step that you essentially can share. So you can generate multiple mid-states, and for that you need the upgraded protocol. The rumors also even said, okay, but how did Bitmain use this advantage? Because they didn't have support, but they actually had kind of a support for it. The mining protocol couldn't accommodate like the version bits and stuff like that to do it in the overt way, but you could do it in the covert way, where you would find certain collisions in the SHA-256 in like 4 bytes. That's like really collision to the full hash function. And then you could generate enough mid-states for the chips and then use the ASIC boost to your advantage. However, this feature was not available to all the users, which was kind of puzzling. So an analogy would be like, can you think of you buy a sports car, but the manufacturer says your speed limit is 100 kilometers per hour, and you can't go any faster, and just that's the limit. This was another reason why we're thinking, okay, let's do something in the ecosystem. Let's try to come up with an open source system that would be an alternative, an aftermarket alternative firmware to whatever the manufacturers provide. And considering that we're not like successful in the previous business model, like, okay, let's just do open source and move on from there. Another affair that was even more puzzling than just the ASIC boost, which is just putting somebody at an advantage, was an affair called Endbleed. That's the official graphics. I took it from the authors from GitHub. Where there was like a bonus feature in the S9 machines where they call it the management feature, but essentially it goes down to the fact that you were able, or actually the manufacturer would be technically able to shut down the machines remotely. And this has been like proven, and then if somebody goes to GitHub and finds the repositories, you would see that Bitmain actually fixed that piece of code, claiming this was actually a bug, but this was really a feature. So another reason why you would want to have some auditable firmware that you can, let's say, trust. Another interesting part of the ASIC boost, and that's a question for the audience, is like, how did we really find out about it? Like, what got us interested in like trying to exploit if we can really make S9 do the ASIC boost? So who think is the A? We were fixing a Zcash miner. I mean, we were trying to get it to mine with our pool because we still support, we're actually quitting Zcash mining. Okay, 2. We did a very thorough analysis of the FPGA code and like that reverse engineering. Okay, few. And a friend told us about the same amount. So it's actually an A. It's like a ridiculous thing. Like we were analyzing like why doesn't a Zcash miner work with our pool at the Zcash endpoint? And like all of a sudden, like I was actually looking at it and I saw like they were submitting like version base that have nothing to do with the Zcash mining protocol. Like they're not being used in there. And then I was like, okay, maybe we should look if they reused that part of the firmware in Zcash, even though it's a completely different protocol, but the front end would be pretty much the same. Maybe there are some chances that the S9s actually do have it. And at the same night, we just tried like really enabling it, and I explained how we got to that information, and it worked. So it was producing like, or it was taking less, let's say by 10 or 15% of power. You would see it immediately on the wall, but the results were all incorrect. So technically, we got the ASIC boost working, but the reason we couldn't use it in production because the results were all crap. And there was no documentation how to fix it, whatever. What we had in the early days, so these were the S9 times, we still had the CG miner sources. It's not very well known, but Bitmain was really publishing the sources. They quit after the S9s. You would still have bits and pieces of the operating system. So if you were a knowledgeable embedded systems engineer capable of like really putting all these bits and pieces together, you could land with a firmware image that would, let's say, would be yours, and you could audit it and trust it. But again, like it wouldn't be like make, install, or make, run, whatever. It would be very involved. So another reason why we started the Brains OS initiative. You would actually have root access to the machine. So you can SSH to the machine, you really own it, you're a root, you can do whatever you want. If you want to use it as your alarm clock, you can do it. And there were actually data sheets for the ASICs, not like super complete, but to get the idea how the ASIC chips work, these were like downloadable on their website. What we have nowadays with the new generation is that we have secure boot. You would think, oh, that's good. That's a quality upgrade because there were affairs with like viruses entering the mining machine. So basically, the control board has a special feature where you basically can enforce only certain firmware that can be booted on it using public-private cryptography or like signing, and they enabled it for their own advantage. Which you would say, okay, it sounds good, but it's not like end-user security. So it's not you as a user who bought the machines are going to enable secure boot, and you're going to use your own keys that you basically generated on site for securing your firmware and making sure like no other harmful thing gets into your machine. It was just the other way around, or it is. That's the current state of the art among all the manufacturers. Most of the machines don't have SSH access anymore, or if they do, it's limited to certain users, so you're not the master of the machine. And there are no sources, no source code ever available, even though all the machines are still running basically a CG miner code base, so it's sort of a violation of the GPL, which, I mean, is kind of questionable. At some talk today, I heard the saying like, not your coin, it's not your Bitcoin, right? It's the same case with the firmware. The question is why I'm showing the car and the miner. I believe that manufacturers are trying to substitute safety for security and the other way around, and they don't understand what it really means. With safety, like you wouldn't want your customers to really modify the firmware in the brakes of your car because bad things could happen. So car is considered to be a safety critical device. Whereas the miner is not safety critical, but it's a security critical device because the miners are actually securing the Bitcoin. If we don't have these boxes in millions and millions pieces around the world, we would not have any Bitcoin because you can fork the blockchain however you want. So for the security, you actually want for the users to have a full control of the machines. Otherwise, it's still questionable like what is really running inside of it. And you would want the users to actually be able to select what firmware they were on, even if it was stock firmware, whatever, but they should be able to do it and they should fully own the device. And that is not the case. Like you pay 10K, whatever, I don't know what the current prices are, a couple thousand USD for something that you're not in full control of. What about the future? I believe the future is bright in a way that we can see that the big mining operations are really pushing hard onto the manufacturers to have the freedom to do anything with the machines. And not just that, but like us in Brains, we try to bring some standardization into the firmware area or in the mining machines area in terms of like today, when you buy a machine and you're a big farm operator, it's up to you what monitoring system you use, but the machine doesn't really have any standard support. It doesn't have any standard API that normal DevOps engineer who is used to monitoring applications running in AWS could use. So we try to step in that direction. So for example, BrainsOS nowadays has a Prometheus endpoint. So if you want to monitor all your, the full cluster of the machines in your farm, you can use standard tools, Prometheus in combination with a nice Grafana dashboard that we provide as an open source thing. You can do it. And I think this is the future because the diversity and if what is planned for this year, I'm seeing like a lot of companies are trying to produce the machine. We will need some standardization because otherwise like integrating every different kind of machine into an existing farm is going to be a big problem. So we're trying to push in this direction. That would be it for me.
I think it's the first talk we have like proper minutes for questions. Thank you. Some questions? No? So thank you, Jan. Woo! Okay. So now I'm lost. Now that we have time, I'm lost. I want to call on stage Andri. And this topic I'm really interested. Why Rob Bitcoin sucks? Not here? No, because we're early.